Percent composition. We have been able to calculate the molar mass of a material if we know its formula already. However, what if we encounter an unidentified substance? We actually have the tools in place to determine the composition of a substance if we have certain pieces of information. Let's see what they know. Let's see what they are. One such piece of information is the percent composition, or the percentage of a compound's mass made up by its various elements. So over here with potassium chromate, it tells you that you have 26.8% of the mass is chromium, 32.9 is oxygen, 40.3 is potassium. Over here to the right, potassium dichromate, what would you expect with the percentage of oxygen in this case, and chromium, and potassium? Well, potassium should go down because it's basically, you've got 2 atoms of potassium, you've got 2 atoms of chromium, so that should go up. Let's see, does that happen? Yep, 26.8 to 35.4. Notice it doesn't double because we're adding different subjects with different masses and different percentages. The math just isn't that easy. Oxygen should also go up, and it does. Only by 6% though, even though we've added 3 oxygens. Of course, oxygen's lighter than these other elements, perhaps. Percent composition. The percent by mass of an element in a compound is the number of grams of the element divided by the mass in grams of the compound multiplied by 100%. So the percent element here is number of atoms times the atomic weight divided by the formula weight of the compound times 100. So let's figure out the percent composition of carbon and hydrogen and ethane, which is C2H6. So let's start with carbon. We have 2 carbons. The atomic mass of carbon is 12. The mass of the compound is 30. And why is that? Well, let's see. Carbon 2 times 12 is 24. We have 6 hydrogens. 6 times 1 is 6. So the compound is a 30 atomic mass units. Multiply that by 100, get 80%. Hydrogen do the same way. There's 6 hydrogens, each one atomic mass unit. Again, the total weight of the compound is 30, multiply it by 100, and we get 20%. There's actually an easier way to get hydrogen there, because you've only got 2 elements. So if the percent composition of carbon is 80%, we have to go up to 100% to get the entire compound. So we just do this over here. We say the percent of hydrogen is 100% minus the percent of carbon, 100 minus 80, 20%. Both ways work. This actually is a little cuter, it's quicker, and it shows that you really understand what's going on. Here's our result. Hydrogen is 20% of ethane and carbon is 80%. Note, and again we said this a couple slides ago, there are more atoms of hydrogen, but there's much less percentage of mass in the compound than of carbon. That's because 1 carbon atom is 12 EMU and 1 hydrogen atom is only 1. So carbon accounts for a much greater percentage of the mass of ethane than hydrogen does, even though there are more hydrogen atoms.